Hi, I'm Ann and I'm an AmeriCorps member with the UC Davis Tahoe Environmental Research Center. And today we're here in the Tahoe Science Center and I'm standing on our 2/3 scale model of the research vessel that our researchers at TURC take out onto Lake Tahoe to collect data and understand how the environment is changing at Lake Tahoe. I'm going to go through a couple different tools that our researchers at TURC use on our research vessel to understand these conditions in the lake. So follow me over here. First, we're going to take a look at our phytoplankton net. This net is dragged behind the research vessel to collect in this bottom container different phytoplankton and zooplankton. Once this net is dragged through the lake and phytoplankton and zooplankton are collected, researchers bring them back here to our labs in our Tahoe Science Center to analyze. Another tool that's used on our research vessel is a Van Dorn sampler, seen here. Our Van Dorn sampler allows us to collect water at different levels in our water column. So I can't actually really sit here on our model of our research vessel, but our researchers release the Van Dorn sampler and it goes down into the water, and they'll send a weight down the line that will actually trigger these two caps to close on each end of our Van Dorn sampler, capturing the water at whatever depth they release it to. It can go down hundreds of feet into the water and help scientists analyze the nutrients, phytoplankton, and other organisms that are living at that depth in the lake. Our third measurement tool on our research vessel is a Secchi Disk. Similar to the Van Dorn sampler, researchers can release our lever here and send our Secchi Disk deep down into Lake Tahoe. A Secchi Disk is used to understand how clear Lake Tahoe is, or what scientists and researchers call a clarity measurement. We have an example of a Secchi Disk here, just the disk itself, but you can see we have a weight on the bottom of our Secchi Disk that carries the disk down into the water column as well. Our Secchi Disk helps us understand clarity of our lake. So as the Secchi Disk drops into the lake, our researchers watch the Secchi Disk down through the water, and at the point that they can no longer see the Secchi Disk, they measure how deep in the water our Secchi Disk has traveled. At that depth, they record the clarity reading for the day for Lake Tahoe. We use this white plate here down into the lake to take a clarity measurement every 10 days in Lake Tahoe. And throughout the year, those clarity measurements are averaged and then reported, and our clarity of Lake Tahoe, the first measurement was taken in 1959. And TURC researchers continue to take these measurements all the way to today in 2021. So we have a really wonderful record of how the clarity in Lake Tahoe is changing. If you follow me over here, we have a record of all of the Secchi measurements that have been taken back to, this graph only goes until I think the first measurement it reports is 1967. But as I was saying, our UC Davis TURC researchers have been recording clarity at Lake Tahoe for a long time. And if you look on our graph, you can see the trend line that's been added to show how clarity has been decreasing in Lake Tahoe over this time period. There's a lot of different factors that go into play when we're talking about clarity in any lake, just like Lake Tahoe. One of the main concerns and why our researchers hypothesize clarity is decreasing in Lake Tahoe is because of the sediments that have been introduced to the lake. On our research vessel here, we have several sediment samples that help us understand how sediments of different sizes can affect the clarity of Lake Tahoe. Lake Tahoe is surrounded by granite and lots of granite rock that's broken down into small pieces over time. And we can see in our first example here, we have large rocks that represent that granite and those granite gravel pieces that are commonly found at Lake Tahoe. But we also have lots of emissions and other sediments that we can see here of different sizes. We have finer sand, we have silt, and we have clay particles. These smaller fine sediments can come from things like car exhaust pipes and runoff that actually suspend differently in Lake Tahoe than are more commonly found large gravel pieces. I'm going to shake up each of these containers and we're going to watch over time how these different sediment sizes actually settle out in our Lake Tahoe water. And we'll let these sit for a minute so we can watch them settle out. So as we can see here, after waiting for our sediments to settle out a little bit, our gravel, the water with our gravel, is pretty clear in comparison to our clay, which has remained very sediment heavy. And if we think about how these different sediment sizes, if they get into Lake Tahoe, can affect the clarity, and as we know there's been more urban development in the Lake Tahoe basin, we can see how more fine sediment particles like our clay can ultimately be something that's influencing why our clarity graph is showing clarity decreasing over time. The researchers here at Lake Tahoe will continue to take clarity measurements and continue to understand what factors might be affecting the clarity of Lake Tahoe. There's already been measures put in place, such as best management practices to prevent sediment runoff and that fine particulate matter taken in the Lake Tahoe basin to protect Lake Tahoe's clear, beautiful waters. Thank you so much for joining me on our tour of the research vessel here today, and I hope you can enjoy all of the other virtual tour series videos that we have on our YouTube channel.